Look, we're completely skipping the fluff today. If you've ever walked out of an exam feeling like your perfectly logical answers are somehow magically losing points in your Cambridge IGCSE computer science papers, well, you're in exactly the right place. In this explainer, we're going to extract the exact wording that literally pulls marks right from the examiner's pen. We like to call this the mark magnet strategy. We're breaking down the components of a computer network, but we're not just doing it so you understand them. We're doing it so you know exactly how to write about them to lock in those top band grades. Let's get into it. So, think about your classic everyday student answer. A network connects computers. I mean, it sounds true, right? It makes sense. But here's the catch. In the Cambridge 4780 exam, this generic zero-mark answer will absolutely destroy your grade boundaries. It just lacks that precision, that technical depth they're looking for. Over the course of this explainer, we're going to unlock the exact mark scheme-approved wording that takes a super weak response and upgrades it into a top-band answer. All right, let's go ahead and replace that zero-mark answer with the strict Cambridge definition. Here it is. A computer network is an interconnection of various computer systems located at different places, designed to share resources and communicate data through links. You really got to notice the specific vocabulary here, okay? Interconnection, share resources, and links. These aren't just, fancy words to sound smart. They are the exact concepts the examiner's actively scanning your paper for. A network is never just about the physical cables. It's always about the purpose of those cables. And that purpose? Sharing and communicating. Okay, let's dive into this next concept, because a network is entirely made up of these active participants. We're talking about nodes. A node is literally any individual device on the network that's capable of sending or receiving data. Now, a lot of students, they'll just write computer and move on, but a node could be a printer, it could be a server, or honestly, any piece of hardware that actively participates in the data exchange. If it can send or receive data across those communication channels, boom, it earns the title of a node. So how do these nodes actually build into a network hierarchy? Well, while all servers are nodes, not all nodes are servers. The server is the authoritative computer here. It's the specific device dedicated to providing resources to the other computers on the network. Actually, think of it like a librarian. The librarian is holding all the books, while the other nodes are just the readers asking to borrow them. When an exam question asks you about resource management, the server is the exact device you need to name drop, for sure. Now, there's a really crucial difference in the software that runs these various machines. A local operating system, think MS-DOS or Windows XP, is designed purely for personal device access, letting you print to a local printer or access a hard drive sitting right in front of you. But a network operating system, that is an entirely different beast. This is the powerhouse software running on those servers. Its entire job is to manage, route, and basically allow all these totally separate computers to securely communicate over the network. To really grasp what we use all this interconnected hardware and software for, we can break network applications down into 3 exam-approved categories. First up, under sharing, we aren't just talking about sharing files, we're sharing physical hardware, like printers and storage devices. Then, under communication, we've got things like FTP, IP phones, and video conferences. And finally, under processing, we're looking at high-level, heavy-lifting tasks like parallel computing. So when the exam asks for network advantages, please don't just say it's faster. You want to pull a specific noun right from this exact technical toolkit. Okay, so we've got all these nodes, servers, and network operating systems sharing massive, massive amounts of data. In just a second, I'm going to give you a massive examiner clue regarding transmission protocols that you absolutely need if you want full marks. But first, we really have to ask ourselves, with all this chaotic traffic flying around, how do these nodes actually guarantee orderly, error-free data exchange? I mean, how does it all happen without everything just crashing into each other? The answer is rules. Strict, non-negotiable rules. Specifically, the fundamental protocol suite that governs all this communication is TCP/IP. That stands for Transmission Control Protocol and Internet Protocol. Look, you don't need to be a certified network engineer to pass this exam, but you do need to know that these protocols dictate exactly how data packets are transmitted, routed, and received. Think of TCP/IP as the underlying grammar of the network. It's what ensures reliable, error-free data exchange no matter where these nodes are physically located in the world. Right, let's shift gears and look at the actual physical hardware sitting in the middle of these connections. Let's talk about a hub. A hub is essentially a distribution center. It's a hardware device that just simply splits a network connection out to multiple computers. When a request comes in from one cable, the hub acts as a sort of central intersection point. But exactly how it handles that data, yeah, that is a major, major focal point for Cambridge examiners. So, the absolutely crucial point here is understanding the exact three-step cognitive process the examiner expects you to write down when you're describing a hub. Step 1. The hub receives the request through an incoming cable. Simple enough. Step 2, and listen closely because this is where the marks are. The hub transmits that request to the entire network. It does not filter, it broadcasts. And then step 3, it's entirely up to each individual computer on that network to check the data and figure out if that broadcast was actually meant for them. Let's test this out really quick with a scenario challenge. I want you to actively think about this one. Imagine a school network uses a hub to send a highly confidential exam file to one very specific printer in the administrator's office. Based on that three-step broadcast mechanism we just walked through, what's the major technical risk here? Think about the specific nouns in this scenario: the hub, the confidential exam file, and the printer. What could go wrong? Okay, here's how a generic, rushed answer reads. The file goes everywhere, so it's bad. Honestly, that earns 0 marks. But the top band mark magnet answer, it applies exact scientific reasoning. It says the hub broadcasts data to the entire network. Therefore, unauthorized nodes will receive the confidential exam file. Do you see the difference? You've identified the hardware's exact mechanism, broadcasting, and directly linked it to the scenario's consequence, unauthorized nodes getting confidential data. That right there is exactly how you pull marks. To consistently write answers like that, you've got to follow these non-negotiable IGCSE exam strategy rules. First, use exact technical terms, words like node, server, and broadcast. Second, avoid trade names. Don't say Mac or Windows unless the question specifically forces you to. Third, always apply your answers directly to the scenario nouns provided in the prompt. Fourth, remember that 1 mark normally requires 1 distinct technical point. And finally, whatever you do, do not repeat the same idea using slightly different words hoping it counts twice. Trust me, it won't. So how do we actually put all of this together when you're staring down a blank page? By using this 5-step answer upgrade framework for any high-level written response. Step 1, state the definition of the component. Step 2, explain its mechanism, like how does it actually work? Step 3, apply it to the specific scenario example they gave you in the question. Step 4, state the clear consequence, advantage, or risk. And step 5, always mentally check that you are using precise examiner wording. If you follow this blueprint, you are literally leaving 0 marks on the table. If you want to keep mastering these mark schemes and turning your knowledge into actual, tangible exam points, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. All right, so we've successfully conquered the components of a network today. But honestly, knowing the definitions is only half the battle. Ask yourself this: if a school network suddenly doubled in size overnight, would a hub still be the safest choice? Or would the whole system just completely collapse under the weight of its own broadcasts? Evaluating those complex setups is exactly where the hardest marks are hidden. If you don't know how to structure an evaluation question, all this technical knowledge we just covered won't save your final grade. So click on the next explainer on your screen right now to uncover the top band evaluation framework for computer science, and I'll show you exactly how to secure those final crucial marks. See you over there.